Okay. Now we will solve the problem again on the forced convection. Okay, in that forced convection, we are going to solve the problem on this. A refrigerated truck is moving at a speed of 85 kilometer per hour, where the ambient temperature is 50 degrees centigrade. That means, till now, what is the problem he used to give? He used to give some material, some body, either it may be plate, disc, cylinder, or a sphere, where the air is moving, air is blowing at certain speed. Now, what he has given, instead of giving the air is blowing over the surface, he has given some other way. He has given some other way that assume that there is a truck. This is a truck. Okay, this is a truck where the truck is moving. At what speed it is moving? It is moving at a speed of 85 km per hour. That means, okay, I'll take this face this side. Okay, this truck is moving at a speed of 85 km per hour. That indicates indirectly the air is blowing in opposite direction, correct? If the truck is moving at certain speed, the air will be moving in the same speed in the opposite direction. That is the meaning. That means instead of giving the air is moving at a speed of 85 km per hour, he has given truck is moving. It is nothing but the same. So now, assuming the truck is moving in this direction of 85 kilometers per hour, this is not required to solve the problem. We want what is the velocity of the air. Velocity, instead of giving velocity of the air directly, he has given like that. So U infinity is equal to 85 kilometer per hour. We want in meter per second. So 85 into 1000 divided by 3600. What is U infinity? U infinity 23.61 meters per second. That means air is blowing above the truck at a speed of 23.61 meter per second. Okay, indirectly he has given. Next, what is the temperature of the ambient air? That means T infinity is 25 degrees centigrade. The body of the truck is a rectangular shape. Okay. Now what he is telling, you don't consider everything, entire thing like this. You consider it as a truck of rectangular shape. So what I will do, I will assume the truck has a rectangular shaped body. This is a truck.
The T infinity is 50.
Yeah, that's, oh, T infinity is 50. Yeah. Oh, sorry. Now this is the truck where this truck is moving, so the air is blowing over the surface. Next, what is given? The rectangular shape of size 10 meters. So we take this as 10, 4, and 3 dimension of the truck. Assuming boundary layer is a turbulent, so he himself has given it as a turbulent already. Turbulent, and the wall surface temperature is 10 degrees centigrade. That means T wall, TW is 10 degrees centigrade. Neglecting the heat transfer from vertical front and back side of the truck, and flow of air is parallel to 10 meter long. That means the air is flowing towards this, towards the length of 10 meter, air is flowing. Calculate the heat loss from the 4 surfaces. Oh, he's asking a Q from all the 4 surfaces. What is the heat loss from all the 4 surfaces? He's asking. So we'll let us solve this. So first and foremost step is T film. T film is T wall plus T infinity by 2. So this is 50 plus 10. 60 by 2 is 30 degrees centigrade. So second, what is blowing? Air is blowing, no? So the fluid is air. So take the property of air at 30 degrees centigrade. What are the property will take? Rho, mu, Cp, K, Pr. These are all. Cp is also not required. Pr is enough. Rho, mu, Pr, and K. This is enough. So this is 1.165. This mu, I don't have. You check out what is this. Prandtl number 0.701. K, I got 0.02672. Can you tell what is mu value? Mu.
It's 18.63 into 10 to the power minus 6.
18.63 into 10 to the power of minus 6. So just I have taken the values from the property sheet in the data handbook. In some problem, he will give the property. Assume that he will give the property of rho P. What he'll give, I'll write here. He'll give the property of rho, kinematic viscosity, K, Cp, and Pr. So here mu is not given. You should find out the value of mu and keep it. Okay. In some problem, he will not ask you to check out the data handbook. He will give, assume the property of air at 30 degrees so much. He will give the values. But here we want mu. Mu is not given. You're supposed to identify what is the mu value. Okay. Is it clear? Okay. That's how we have to find out. In some problem, what he will give? In some problem, he will give like this, and also he will give alpha value. So what is required for us? Alpha is not required. We want only these four. Okay. PR is given. K is given. We want mu is given. We want rho. To take out rho, what to be done? Either kinematic viscosity should be given, or else he has given like this. Alpha is equal to K by rho Cp. We know alpha is equal to K by rho Cp. Use this equation. Take out rho from this and take the value of rho. Understood? So these are all the basic equations. This is all these equations are available in data handbook. So what is mu? Mu is equal to rho into kinematic viscosity. This is also there in data handbook. All the formulas are there. Just you have to put up whatever the data he has given, whatever he may give, you convert into this form. That's all. Rho, mu, PR, K. That's all we want. Clear? That depends upon the problem. In some problem I observed the question paper there, he has given alpha. He has not given rho. So by using this equation, alpha is equal to K by rho Cp, thermal diffusivity. Take out rho, substitute it. That's all. So like this, you're supposed to take the properties. Then, once you take the property, third step is Reynolds number. Reynolds number, hence we know already it is turbulent. No need to find out. But this Reynolds number value is supposed to substitute in further stages. So let us find out for Reynolds number. So what is the Reynolds number formula? Rho V L by mu. Why I taken L again? Because air is moving at a length of 10 meters. So rho is 1.165. Velocity is 23.61 into length is 10 meter divided by mu. 18.63 into 10 to the power of minus 6. Can anybody tell what is the Reynolds number? What is the Reynolds number?
Sir, it's 1476
1476
4796.
Okay, this is the value of Reynolds number, which we know it is a turbulent flow, because if it is less than 5 into 10 to the power 5, it will be laminar. If it is more than that, it is a turbulent flow. Okay, that means, see, this is air and this is the body where air is flowing like this. This is the cross section where the air is obstructing first. This is the cross section where the air is obstructing. So we have to consider this cross section. Concentrate on this concentration on this cross section a lot. Vertical height is 4. This is 3, and the length of the truck is 10 meter. So we have taken 10 here because the air is flowing over the entire length of the truck. So we are taking the 10 meter as a length. Then what you're supposed to do for a turbulent flow, non-circular section, go for the data handbook. Turbulent flow, non-circular or a non-cylindrical section. What is the Nusselt number value? Can you take out Nusselt number value for a turbulent flow? Can anybody tell? Nusselt number for a turbulent flow. See, if you know how to read the data handbook, then this chapter is nothing. Which Nusselt number I supposed to take? That you're supposed to be known. I'll tell you what is the page number if you are not able to find out. See, it is an external flow over the bodies. Check out what is the Nusselt number we use. Here. Again, I think probably in page number 117 it might be there. You please check out. I think Nusselt number 0.0296. That formula is there. Page number 117. It is not there here. It is not printed in my handbook.
Yes, sir, it's not there.
Okay. I'll write the formula. You check out with the data handbook what you are having. If you are having the data handbook, you please check that. Okay. 0.0296 Reynolds number to the power of 0.8 into Prandtl number to the power of 0.333. This is the Nusselt number for the given arrangement. Only thing is you should know which Nusselt number I am supposed to take. That's all. Okay. Next, if you go for this Nusselt number, we will get as 14302.15. This is the Nusselt number. We see, Gautam, I told you to share the data handbook. No, Gautam.
Yes, sir. Yes, sir.
See, because of this, if data handbook is not there, I cannot explain. You check out. This is the data. This is the formula I got from the data handbook. You check out where is this formula for which it is corresponding. Find out and write the answer. Okay. Done.
The missing page I shared, sir.
Huh? You know?
That missing page is there. Right. I shared the missing page now, sir.
The missing page, earlier you shared only 113, page number 113. Now I observed it is 117 is also missing.
Okay, sir. I'll send the whole chapter.
Whole chapter if you send, no, so that will be easy. Okay.
Yes, sir.
Okay, this is done. Nusselt number is done. Okay. Then you have to find out H from this. H is equal, Nusselt number is equal to HLC by K. Nusselt number is equal to H LC by K or HL by K. You find out the value of Nusselt number. Sorry, you find the value of H.
So 38.24.
What is that? H.
Yes, sir.
H is 38 point, very good. H is equal to 38.24 we got. Okay. H is equal to 38.24. Substituting that H. Wait 1 minute. Okay. You find out the Q. Here it is important compared to all the problems. H A delta T is the Q value. So H is 38.24. Area is, what is the area you will take? Area you will take as, he is asking all the four sides, means if the truck is this, he is asked, this is one side of the truck, other side of the truck, other side is back, below is other side. He is asking the what is the heat transfer from this surface, other surface and bottom, and again at the bottom. So what will be the formula? 2 into 10 into 4. 10 into 4 that side and this side, plus 2 into 10 into 3. This is the area. Here T infinity is 50 minus 10. In the last problem, what we did, do you remember? Do you remember what we did in the last problem? Just we had taken 4 into something value. Why? Because it was a square. The section was a square. So we have taken 4 into that cross-section area. But now we are taking this entire length 2, again 2, because it is a rectangular section. We are supposed to take like this. Find the value of Q. That's all change in this. area. If the rectangular shape is given, what to take the area, and if the square shape is taken, how to take the area. That is important. Done. What is Q?
Sir, it's minus 2 and 4, 144.
Okay, minus why it is minus? Because the air temperature of air is greater than the temperature of wall. Heat is taken away from air to the body, the truck. It is 2.
Minus 2 and 4,
Okay,
144.
watts. So this much of amount of heat is taking from air to the truck, from all the taken by air to taken by the truck from the air. Here you should know what is the previous problem and this problem is same. Previous problem, case 2, is what? There was a rectangular, there was a square section like this. We have solved the same problem by using the square cross section. Now we are solving by using the rectangular cross section. That's all. Yesterday's problem, case 2, and today's problem is similar except this area. Other than this area remaining is same. Okay. I hope it is done. Okay. After this, problem is again forced convection, where the convection taking place inside the bodies. If the convection is taking place inside the bodies, so till now what we did, if the air is blowing above the surface, we know how to solve. If it is a cylinder, if the air is blowing above the surface, you know how to solve. If it is a sphere, air is blowing on the surface, how to solve the problem based on forced convection, that is known. And if it is a not a cylinder, if it is some section, either it can be square, rectangle, triangle, trapezoid, anything, whatever may the cross section, if that is a shape, that is a prism given, you know how to solve the problem. Right now, I have solved the problem 2. One is on square, one is on rectangle. See, if it tells that, assume that truck is a triangular shape, then what will be the area? Till here, everything will be same. The area will be changed. What is the area of the truck? You have to check out what is the area for the equilateral triangle. See, if this is the case, you won't give triangle, just I'm telling. If the shape of the truck is triangular, all the 3 sides you have to check out means this into that into base, means this plus other side plus base. You have to check out that what is the area of the truck, what is the area of this surface plate, other plate, and then substitute here. That's all changed. So all the problems I covered, whatever it is possible way to ask in exam, I have covered all the ways, all the possible questions in forced convection, external flow. The forced convection itself is divided into 2 parts. One is external flow, one is internal flow. Now we have covered the forced convection, external flow. External flow above the plate, above and below the plate. Okay, I'll write the tree. In forced convection, external flow, internal flow. Okay, in external flow, there is a problem on plates, cylinder, sphere, some prisms. Prisms means right now we did a truck is square in cross section, length is so much, like this. In plates, above, below. So just above and below means add up into 2. All these problems I covered. In a forced convection, all the problems I covered. Now I'll go for the internal flow. Internal flow means what? Only one concept, that is there will be a tube. There will be a tube. Inside the tube, hollow cylinder, if the air is blowing or any liquid or air or liquid, any fluid, if it is flowing, what is the heat transfer between the fluid and the pipe? That we are going to solve by using convection. What is the heat transfer between the pipe and the fluid? By convection, we will solve now. Clear? Only this is there in the internal flow. I think probably tomorrow I will complete this internal flow. In the next class, I'll wind up the internal flow concept. That means by Saturday. By Saturday, I'll wind up the internal flow. Then I'll go for natural convection. Today we'll solve this problem. If the air or fluid is flowing inside the tube, I will solve. Then you may ask, sir, what we did in the first chapter? In the first chapter also almost similar. There was a pipe where the fluid was flowing inside, hot fluid was flowing inside, and heat transfer taking outside we solved, no? Outside heat transfer is taking place. That means if I draw this cross-sectional view, it was like this. If there is a pipe, Ti, Hi, T0, H0, if the pipe material is having some thickness, we used to know T1, T2. But there what we did, we did not concentrate on how the heat transfer taking place from fluid to material. Just we have concentrated heat transfer between the material. Between this, what is the fluid heat transfer taking place? Which between the thickness of the material, how the heat is transferring. Now, what we are going to do, we are going to solve the problem based on how this inside fluid and inner surface of the tube is transferring the heat. That we are going to concentrate in this chapter. Okay. So for that, I given a problem. What is the problem given? Can anybody read out? Can you read? Hello.
So water at a velocity of 1.5
Yes,
meters
yes.
per second.
Okay. See here, some procedure is somewhat changes. You observe what is the change in the procedure. Apply the same procedure for all the problems internal flow. If it is internal flow, you follow the same procedure. Now you observe what is the fluid. Fluid is water. That means water is flowing inside the tube. Now we are solving internal flow. Water is flowing inside the tube with a velocity u infinity 1.5 meters per second. Within what? It is flowing at 2 centimeter diameter tube. That means diameter of the tube is 2 centimeter. 2 into 10 to the power of minus 2. How much it will be? 0.02 meters. This is the tube. And diameter heat exchanger tube of 40 degrees centigrade. That means, okay, I'll show you the figure. If this is a tube, water is flowing inside the tube. What is the temperature of the water? Here is given 40 degrees the temperature of the water, and the heat exchange between the tube wall is maintained at 100 degrees centigrade. The heat exchanger, the tube wall. The surface of the tube, this temperature is maintained at 100 degrees centigrade. This is called T wall, TW, and this is called tube fluid. If the water is heated to a temperature of 80 degrees, so once it is entering by 40 degree, the surface of the tube is 100 degree. Once it is going out, the temperature of the fluid again it will be 80 degrees centigrade. Okay. In the heat exchanger tube, find the length of the tube required. He is asking you to find out the length. See, in natural convection, how many temperatures we come across till now? We know only two temperatures. One is wall and other is fluid. Only two temperatures we came across till now. That means what is the temperature of the wall and what is the temperature of the fluid which is flowing over the surface. But in the internal flow, we'll come across three temperatures. Remember, whenever the flow is taking place inside the tube, we will come across the three temperatures. What is the three temperature? One, as it is, the wall temperature, the temperature of the surface, the cylinder. Okay. And other is the fluid temperature inlet and the fluid temperature outlet. Three temperatures will come across. So first, all of you open the data handbook of internal flow. I'll show you how to calculate, how to take that. Internal flow. That is page number 123. Can you please open the page number 123? In the data handbook, what I have shared. Page number 123. Page number 123. Open? Hello?
Yes, sir.
Okay. There can you see the beginning itself he has written the note. What is the note he has written? Properties to be evaluated by the bulk mean temperature. For the external flow, the properties to be evaluated for film temperature. Film temperature formula is what? Tf is equal to T wall plus T infinity by 2. So all the properties we supposed to take to the film temperature. Now we supposed to take the property for bulk mean temperature. What is that bulk mean temperature? He has given the formula. So the first step will be that. Can you tell what is that? T mean, that is nothing but bulk mean temperature is equal to T of T of Mi plus Tm naught, okay, Tm naught divided by 2. What is this Tmi and Tm naught is? Tmi is the temperature of the fluid inlet, temperature of the fluid outlet divided by 2. So here we are nowhere concentrating on the temperature of the wall. We are concentrating on temperature of the fluid to find out the properties. Inlet fluid temperature, outlet fluid temperature by 2. Here we are finding. So what is this? 40 plus 80 by 2. So how much? What is the bulk mean temperature? Tm? 60 degrees centigrade. This is a very important change in the external compared to external flow and internal flow. In the external flow, we will take a ratio of wall temperature to fluid temperature by 2. We will take the ratio of wall and fluid temperature. Here, wall temperature we are not considering. We will consider only the temperature of the fluid, bulk temperature of the fluid. Okay. So bulk temperature inlet and outlet, ratio of inlet and outlet temperatures we'll take, and this is a Tm. So execute the property or take the properties of Tm, that is bulk mean temperature, not Tf. Tm for internal flow, we are supposed to take the fluid properties at bulk mean temperature. So the further step is same, further procedure is same. Only change in this is we will be having 3 temperatures. One is Tmi. So I'll write this. This is called Tmi. This is called Tm naught. Tmi, Tm naught, Tw. So concentrate on Tw, forget right for time being. Concentrate only Tmi, Tm naught, and then find out T mean, T bulk mean, temperature of the bulk mean. Then you take the property at 60 degree for the given fluid. What is the given fluid? Whether the given fluid is here? No, the given fluid is water now. For water at a temperature of 60 degree, you take the properties. Same property, whatever the properties we have taken till now, same property. You take that. Shall I have this? Have you taken? Hello?
Yes, sir.
Okay. Figure is very important for the internal flow. You observe for the few problems. First few problems you will be having doubt. What is the difference between internal and external flow? Later on, it will be familiar with you. So once the property is known at 60 degree for water, I'll write the properties. Rho is equal to 985. Then PR is equal to 3.02. K is equal to 0.65. Can you tell the value of mu? If it is there, you tell, or else we'll see. Mu value is there. Open the data handbook. The property of water at 60 degrees centigrade. Take the values of rho, PR, K, and mu. Okay. See what I did, I have not taken the mu value everywhere. I have taken Cp. Cp is equal to 418.3. And then kinematic viscosity I have taken 0.478 into 10 to the power of 6. If you are having mu directly, you can take mu, or else you can take these values. So what is the next step? That is third step. Third step is finding Reynolds number. Reynolds number formula is rho v d by mu. So here rho I am not having. I have taken expressed in terms of nu. So I'll rewrite this equation as v d by mu. That's all. If you have rho, you do with this method. If not, you do with this method. So here v is what is the velocity of the flow fluid? V is nothing but u infinity. U infinity d by kinematic viscosity. Therefore, Re is equal to 1.5 into 2 into 10 to the power of minus 2 divided by kinematic viscosity is 0.478 into 10 to the power of minus 6. So what is the Reynolds number value you got? What is the value of Reynolds number? Hello? Anil? Anil. Okay. Reynolds number, I'll write the values. 6.2 into 10 to the power of 4. 6.2 into 10 to the power of 4. Now again we'll go for the data handbook of internal flow. Data handbook for internal flow. Open the data handbook for internal flow. So based on the Reynolds, why I am opening the internal flow now? Now because I supposed to write the fourth step as Nusselt number. This Nusselt number formula depends upon the type of the flow, type geometry of the flow, and type geometry and whether it is turbulent or Reynolds, turbulent or laminar region. That will come to know which NU I supposed to take based on the given set of problem. What is the given problem? It is an internal flow, and I don't know whether it is turbulent or laminar. We will see. With this value, we will see whether it is turbulent or laminar. In general, no. If the fluid is flowing, here, he has given, in the beginning only he has given, you take for the problems of tubes, laminar condition only if the Reynolds number is less than 2300. If the Reynolds number is less than 2300, then this table holds good. Table number 1, entire thing holds good. We are supposed to take only within this. The table number 2 tells what it is telling. If the Reynolds number is greater than 2300, you will consider that the flow is a turbulent and you go for this table. So what is the Reynolds number we got now? 6.2 to 10 to the power of 4, which is greater than 2300. Hence, turbulent flow. That means water inside the tube, it is flowing in a fashion of turbulent. So take out the NU value for the turbulent flow. That's all we need to do. So only thing is here to decide which NU I supposed to take out of thousands of NU, you select NU. So again you check out here in table number 2, there are so many NUs. NU at entrance region, page number 125. NU at short pipe, NU at fully developed Ditters-Boulter's equation, smooth tubes, there are so many. So you always take, if the turbulent flow is occurring, you take NU as Ditters-Boulter's equation, that is 0.023 RE to the power of 0.8 Prandtl number to the power of N. This is called Ditters-Boulter's equation. This holds good for all the cases. If it is internal flow and turbulent, you can take this equation for all. This holds good for all the equation. This is called Ditters-Boulter's equation and fully developed flow. If the flow is taking place inside the tube and if it is turbulent, you take this Ditters-Boulter's equation as a Nusselt number. In this Nusselt number, RE we got no issue. Prandtl number we got from the data handbook, data handbook of properties. Only unknown is N. What is the value of N? The value of N is given just below that. You take the N value as 0.4 for heating of the fluid and N is 0.3 for cooling of the fluid. Now, inside the tube, what is flowing? Water is flowing. What is the temperature of the fluid at the entrance? It is 40 degree. At the exit, it is 80 degree. That means the fluid what we are supplying inside the tube is heated up. If the fluid is heated, then you're supposed to take the value of N is equal to 0.4. If the fluid is heating, then you take the value of N is equal to 0.4. Substitute here. You get NU. What is the Nusselt number? Everything we got already here. Reynolds number is here. Prandtl number is there. So Nusselt number I got 244.14. Please check out the answer. Don't believe the answer what I written. You check out the answers. Okay, na? Hello. Okay. I hope you have completed. If there is any doubt, please ask me. Huh?
It's 246.5.
Okay, 246. Okay, right. 246. I'll write your own. 246.5. Whatever the value you got, you write down. 1 or 2, I think, because of this decimal. If you take 6.2 into 10 to the power 4, you'll get some other answer. If you take completely 6 to complete value 6, 2, 3, 5, something, if you got whatever the getting you're writing, if you get that, you'll get some other value. No issue. Done. After this Nusselt number, do you remember what is the step to be followed? Find out the value of
H.
H. So to find the value of H, what is the issue? What is the formula? Again, Nusselt number is H D by K. You know all the things here. Take out H. H is equal to Nu into K by D. Nu is known, K is known, D is known. So I'll write the answer, what I got. 7934.64. See, if it is too much varying from the answer, what I got and yours, you please inform me. If 1 or 2, no issue. That depends upon decimals, what you have taken. Watt per meter square Kelvin. That is the value of H. That is the value of H. Then what we did for Q. Q is equal to H A T wall minus T wall minus what we supposed to take here. We supposed to take T infinity. Now instead of T infinity, we will take Tm. This is the change in this. Instead of taking T infinity, we will take Tm. See this? This is the change. So again, we are converting the 3 temperatures into 2 temperatures. That's all here. So what is the H value? H value, you know, 7934.64. Area is pi dl, pi into d into L. This is what we have to calculate into T wall. Is the T wall 100 minus 60. So what is the Q? Can you tell? Oh, Q I cannot find out. Why I cannot find out the value of Q? Because I want L. I want the value of, to find the L, first I want to find out the Q. Or if the value of L is known, Q I can find out. Here in the question, he is not asking you to find out the Q. He is asking straight away to find out the value of L. So this is the equation for natural convection. Okay. What is the equation if the fluid is flowing inside the tube? Can I tell? The Q. If the fluid is flowing inside the tube, the value of Q will be m dot Cp T of m inside, so T of m outside minus T of fluid inside. This is the general equation, no? M dot Cp dot delta T of that fluid. If you do this, we'll get Q again. I can equate these two Qs. The Q value here and here, it is same. So what is m dot? M dot is nothing but rho A V. Cp for 80 minus 40. So what is rho? We got rho no 985. What is the area? Area is pi by 4 into d square. What is the velocity? 1.5. 80 minus 40. So we will get Q in watts. Equate this Q back to this and find out the value of L of the tube.
Sir, area should be pi dl.
Very good, very good. I thought somebody will ask this question. See, what is here? This area is pi. Okay, I'll show you. See now. If I am talking about the heat transfer throughout the length, area will be pi dl. If I am talking about what is the area of, means what is this mass of the fluid which is entering, whenever the mass of the fluid which is entering to be substituted, then area will become, or m dot will be equal to rho Av. That means at some particular cross section, what is the density of the fluid flowing, velocity of the fluid flowing, and area. This area at some particular cross section we are supposed to take. That is nothing but rho into pi by 4 into d square into L. Okay, this pi dl I am supposed to substitute for the q here, but for m, not only here, in any subject, if you want to substitute m dot will be equal to rho ab, and a for this will be pi by 4 into d square. There is a difference in this area and that area. Why? We should know that. This one, what we are taking is only with respect to that particular location. This area is only at a particular location, and this is throughout the length. Throughout the length, how much heat is transferring? I'm typing here. I forgot to write here Cp value. Cp also write. I written rho A V delta T directly. Cp you write. What is Cp? That also you add up. You multiply the value of Cp. Cp we got from the data handbook, from the properties of water at 60 degrees centigrade. What is the value of L? Finally, I'll ask only L value. Could you please tell me the value of L? Can anybody tell?
So is it 3.84 meters?
I'm not having 3.84.
Yes, sir.
I check out. You please, others, you please check out. What is Cp value you taken?
4183.
No, that 4183 is the Cp value at 60 degrees centigrade.
So water temperature is also 60. The Tm value is 60, right? Tm value is 60 now.
Tm value is 60. The Tm is 60, but here while substituting, the Cp should be 4.187 into 10 to the power of 3. Here, while substituting here, the Cp value should be 4.187 into 10 to the power of 3. This is also changed. This is not Cp, this is Cp. See, this equation, what I am doing, this is nowhere concerned with the Tm. This equation, the Q, what I am doing here, it is nowhere concerned with the Tm. This is the basic equation, man. Basic equation where Q is equal to rho AB, Cp. So Cp this should be 4.187.
Okay, got it, sir. Got it.
Okay, you tell me what is this 4.187? If it is 4.187 into 10 to the power of 3, what is the value of Q? Oh, no, sorry, what is the value of L? I want directly the L value. Anybody? How much? Eldro Pavan, Gautam, Nilesh, Prince. Can I tell the value?
So 3.89 only.
Okay, 3.89, huh?
Yes,
Yes,
sir.
sir.
Same only, sir.
Okay, not same. Why? Because the Cp value at Tm we are taken as 418.3. But if you go
Yes,
for general, it will be 4.187. Here it is 4.183. That is the only change. Because of only small change, we got the value of almost L is equal to same. But you should remember, the value of CP should be always 4.187 into 10 to the power of 3. This only we are supposed to take, not with respect to T mean.
Yes, sir.
Okay. Please, all of you type your US number. You can leave the class. If you're having any doubt, you can ask, you can discuss, or else you can leave the class. See, and one more thing, I have updated all the link of the class in the Google Classroom. Please go through the links. Today's class, I'll upload tomorrow, like that. Okay. After 1 day of the class, I'll upload the YouTube link. Please go through that link for any clarification. Thank you.